This video is a quick Key Stage 4 introduction to the link between acceleration and inertial mass. So if you consider an object in deep space, far away from any gravitational field, we can consider that object is weightless. If I were in that situation and I threw a golf ball and a cannonball, I would find it more difficult to throw the cannonball than the golf ball. I would require more force. Now, since both objects are weightless, it can't be anything to do with the weight. In fact, it is due to their mass. The reason it's more difficult to accelerate a cannonball is because it has a greater mass. So, our title today is Acceleration and Mass. Our learning objectives are that we should state the equation linking resultant force, mass, and acceleration, be able to describe how the acceleration of an object depends upon its mass, describe how the acceleration of an object depends upon the resultant force acting upon it, calculate the acceleration of an object, and finally, state what is meant by inertial mass. So I'll set out our notes in the Cornell note-taking style. We have our learning objectives on the left, and within our notes, we will answer the statements in the learning objectives. Finally, you'll summarize what you've learned at the bottom in your own words. So let's start with the equation. F equals ma. The resultant force on an object is equal to its mass, that is its inertial mass, multiplied by the acceleration of that object. So let's look at this in practical terms. If I have two rockets, one 4 times more massive than the other, but they are both being accelerated by the same force of 1,000 newtons. In the first case, the 1,000 kilogram rocket will accelerate at a rate of 1 meter per second squared. However, with the rocket which is 4 times greater in mass, the acceleration will be 4 times less. It will be 0.25 meters per second squared. So if you increase the mass, you decrease the acceleration. Doubling the mass halves the acceleration. Next, we have two identical rockets of 1,000 kilograms. However, the first is accelerated by a force of 1,000 newtons. The second is accelerated by a force of 3,000 newtons. In the first case, we'll find that the acceleration is 1 meter per second squared. In the second, we find that the acceleration is 3 meters per second squared. That means that as you increase the force, you increase the rate of acceleration. So if you double the force, you double the acceleration. So let's look at a worked example. A car of mass 800 kilograms is subject to a resultant force of 2,000 newtons. Calculate the acceleration of the object. Firstly, we write down the variables that we know from the question. We know that 2,000 newtons is a force, so we write F equals 2,000 newtons. We know that 800 kilograms is a mass, so we can write M equals 800 kilograms. Finally, we want to know the acceleration, that's A. We think which equation will be relevant. In this case, we already know it's F equals ma. Then you substitute in the numbers. We end up with 2,000 equals 800A. After substitution, you transpose. So you get A equals 2,000 divided by 800. And finally, you get your answer, 2.5 meters per second squared. Now, in an exam situation, it's good practice to write out the variables first. You can potentially get a mark for writing the equation if it does not give you the equation. And you will get a mark for substitution, a second mark for transposition, and a last mark for writing the answer correctly with the correct units. So finally, let's look at inertial mass. If we rearrange the equation to make m the subject of the formula, we find that mass equals force per acceleration. That is to say, mass, or inertial mass, is a measure of how difficult it is to accelerate an object. That is, how difficult it is to change the velocity of an object, whether that's increasing the velocity, decreasing the velocity, or changing its direction. It's a measure of how difficult it is to alter the velocity of an object.